All right, time for another round of math notes. As always, we start the same way. Please make sure that your name and number are on the top. We are still in Module 1. The fun continues, but we have passed the midway mark. So we're almost, well, a little more than halfway done with your Module 1 notes. Today we're going to be doing Module 1, Lesson 10, Subtracting with decimals. Subtracting with decimals. Subtracting with decimals. This is Roman numeral 10, since it is Lesson 10. So we move on to a new symbol, X. Okay. Subtracting with decimals. We don't have a ton of vocabulary to start with today. Just 2 words. Hopefully at least one of them you've heard before. The other one I think I've used, but I don't know if I've actually stopped to explain what it is. First word is difference, and this is going to come up quite a bit when we are subtracting. Difference is just the answer to a subtraction problem. If you see this in a word problem, or if you hear it in class, find the difference. It means you're going to subtract 2 things. You're going to be doing some subtraction. This is similar to a sum is the answer for addition, product for multiplication, quotient for division. Okay. Number 2. This is the one that I'm not sure you will be quite as familiar with. The standard algorithm. Now, I will give you a better definition, but really, this is a fancy math way of saying subtract the way that you've always been taught to subtract. We are going to practice some other strategies in class. You've probably learned some already. Standard algorithm is just what we're going to be doing in the notes today, and it is what you will probably do most often. Okay? The standard algorithm, and this is true for other operations like addition, multiplication, division, not just subtraction. The standard algorithm is a step-by-step way to solve a math problem. I think I'm going to add in parentheses operation. Again, our operations in math, add, subtract, multiply, divide. There are others, but those are the main ones. The standard algorithm is just a step-by-step way to do it. It's what you've always learned. I'll repeat that a few times probably. All right. Speaking of repeating it, I'm about to repeat it right now because the procedure for today is the standard algorithm. Most of this is going to look very, very familiar. Step 1. Write the problem vertically. Write the problem vertically. Now I am going to add a little bit to it. When you write the problem vertically, you need to be careful to line up the decimal points. Line up the decimal points. Now what you're really doing is lining up the place value that we've been spending so much time talking about. The ones and the ones, the tens and the tens, or tenths and tenths. But I think that finding the decimal point is usually the clearest and easiest way to do that. Let me show you what I mean. I'll slide the paper up in just a moment. 60 and 91 hundredths minus 2 and 856 thousandths. Now, a lot of students will try to write this, the 1 over the 6, the 9 over the... That's not correct. We have to line up the decimal points. So I put the decimal points in first. I'm going to give myself some space. Okay. I am going to put the decimal points over here. And I've mentioned this when we work with place value charts, excuse me. Place value charts, you want to build the number out from the decimal. The first number goes on top. Now be careful. Word problems may switch the order, but once you have it written like this, once you have a number expression, you have a number sentence, whatever's first is going to go on top. Technical term for that is the minuend, if you're curious, but most of you probably aren't. Underneath goes the second number, and again, we build it out from the decimal point. 8, 5, 6. That puts the 6 out here with nothing above it, which might look a little odd, but it's really actually nothing you haven't done before. I'll explain in a moment what we're going to do with that. Okay, so there's my subtraction. I've lined up the decimal points, and I've also again lined up all the place values, the ones, tens, tenths, hundredths, thousandths. For step 2, as we continue with the standard algorithm, step 2, we're going to fill in extra spaces. Make that look like an A. Fill in extra spaces with zeros. Oops. Thank you, mechanical pencil. So going back to the number that we started with, numbers. I'll move it more in the center now. Uh-oh, I didn't write the decimals first. That's okay. I just have to make sure that for the second one, I put the decimal and then at least build that one out. Otherwise, again, I will end up with a weird problem. Okay, there is nothing up here to subtract 6 from. Well, we know how to write nothing. We write nothing with a 0. So I filled in that extra space. Now actually, I could also put a 0 here if I wanted to. I don't really have to. This may not be as obvious on lined paper, but once you start working on graph paper, which in class and on tests you will, I think it becomes a little more obvious. That's one of the big reasons I use graph paper. Once we have that, move on to step 3, which some of you are probably already thinking about or doing. You're just going to subtract as usual. You're going to temporarily ignore the decimal point. Just subtract the way you would normally subtract. Now, a lot of times, that means borrowing. So, borrow if needed. If you need to borrow, make sure that you do. If you need to borrow, make sure that you do. In this case, we will. So we'll write the number again. I'll remember to put the decimals in first this time. Build out, build out. I want to put the 0 this time. Build out, build out. Again, so much better on graph paper because all of those things are beautifully lined up for you. Okay, 0 minus 6 is not happening. So the 0 looks next door and says, hey, can I borrow something? The 1 grumbles, ugh, but says okay, and it moves over. This 1 now becomes a 0. Now, with a group of 10 over here, 10 minus 6 is 4, okay? But now we have the same problem again, 0 minus 5. So let's borrow. The 9 becomes an 8, and it sends over a group of 10. Now this would be 10 hundredths minus 5 hundredths. We are left with 5 hundredths. The tenths column cuts us a break. 8 minus 8. That's nice and easy. 0 minus... Fine. Borrow again. 10 minus 2 is 8. 5 minus nothing is 5. Now I'm hoping you notice there's one thing that I missed. I could really do it right now, but I wanted to make sure that it was its own distinct step. So step 4, drop the decimal point, straight down. Straight down. Drop it straight down. Okay. Rather than make you rewrite the whole thing, I will just go ahead and show you here. It's dropping straight down. Going back to that place value chart, you are just keeping the decimal where it has always been. In the standard algorithm, it looks like we're dropping it down below the line, but really, thousandths, hundredths, tenths, ones, tens. The decimal point hasn't gone anywhere. It's always been here. In fact, a place value chart can help you with this if you would like to use one. Although, again, I really am going to push for you to start working on the graph paper. Now, before we stop the video, I am going to do one more thing. This is going to be a little different. In the past, I have not given you an example without finishing it. But for this one, because I'm hoping that so much of this subtraction is familiar to you, and because we're already at 12 minutes, I am going to write down the problem, and I would like you to solve it as best you can on your own. We'll go over the answer tomorrow. The question I'm going to give you looks like this. Let's do 91 and 49 hundredths minus 7 tenths. So hopefully not too complicated. Remember the steps. Write it vertically. Line up the decimals. If you have any extra spaces, fill them with zeros. You might not. Then subtract as usual. Borrow if you have to. Bring the decimal point straight down. That should be it for this lesson. Hopefully that makes sense. As always, if you have any questions, I'll be happy to answer them in class. All right, folks. Have a good one.